Gravity. It keeps us on the ground, it keeps our galaxy together, and it keeps this ball coming back every time I throw it up. But did you know that gravitational potential energy is the best rechargeable battery we have? Let's see how. Gravity gives objects gravitational potential energy. Energy, or work, is the force we apply times the distance we apply it for. In our case, the force is gravity, but you don't need to remember the equation, just that it increases with the mass of the objects and it decreases as the distance between them gets bigger. And since energy can only be transformed, so not created or destroyed, all the work that I put in raising the object will stay in the object as gravitational potential energy. That energy will stay in the object for as long as it's kept at a height. Coming back to our equation, the gravitational potential energy of an object is just its mass times the gravitational acceleration times the height we put it at. The height is generally measured from a reference point, and we typically use the surface of the Earth for convenience. In case you're wondering, g is just an approximation of the gravitational acceleration we experience, and it's derived from the formula I told you not to memorize. So because the Earth attracts the ball through gravity, it now has gravitational potential energy. Energy that could potentially become kinetic energy when the object falls. Let's understand now how the potential energy formula works through a few examples. We have here a volleyball. It weighs about 120 grams and is half a meter off the table. It has about 0.58 joules of potential energy. If I now take it double the height to 1 meter, it has double its potential energy to about 1.17 joules. Similarly, if I take a heavier ball, this is metal and weighs about 5 times as much as the volleyball, and I rise it to the same height, either half a meter or 1 meter, it now has 5 times more potential energy than the volleyball had. That is because heavier objects at a greater height have a greater amount of potential energy. The keyword here is potential. It means what could be, future, possibility. And what it's saying is that even though this ball is not hot or electrically charged, it still has energy. Energy that can be converted at a later time. This conversion is surprisingly efficient with only minimal losses due to air resistance. And this is great news because in most processes, energy conversion is very wasteful. For example, an incandescent light bulb emits most of its energy as heat and non-visible radiation. Also, energy doesn't like to stay in one place for long. Lithium-ion batteries lose charge over time, even if they are not connected to anything. And some forms of energy cannot even be stored. And yet, energy storage and conversion is crucial for renewables like solar farms, because we need to produce energy right when we need it, but we still need energy at night. So there must be a way that we can harness the power of potential energy and use it as a sort of battery. Imagine this. When your solar panels produce more energy than you need, you simply take the excess energy and use it to lift up a heavy object. As we've seen, this transfers the energy into the object, which stores it as gravitational potential energy. Later, when the demand increases or the production decreases, you can recover that energy from the object. By simply lowering the heavy mass, you convert potential energy into kinetic energy, which can be later turned into heat or electricity as you need. And this principle is used all over the world. For example, some hydroelectric power plants use the extra energy they generate to pump water back up into the dam. They keep it there until the demand for electricity increases, and then they release it, making it flow through the turbines and generating more electricity. For commercial applications, gravitational batteries are more efficient, cheaper, and present less complications than typical means of energy storage. And all of this thanks to Earth's gravity. Thank you, Newton! And thank you for watching this video. I hope we answer all your gravitational questions, but if you're still curious, we have more than 2,000 calculators that will surely meet your needs. If you're looking for another video to watch, I recommend this one that we made recently. And as always, if you enjoyed the video, hit the like button, subscribe to the channel for more videos like this, and I will see you in the next one. Bye!